Hello, I thought I would do a little video about changing this control panel. This control panel is one of the first things that I did when I started building this railroad. And as you'll see fairly quickly, there are a lot of shortcomings on it. Basically over here on this left-hand side, these are just little switches that run double pole, double throw. And they correspond to turnouts back here on the track. There are those two turnouts. That's set of switches that I just threw control. Let me power this up and okay, I've got it all powered up. And when you flip a switch, corresponding turnout will actuate. No big magic there, except in my impotent wisdom of probably 12, 15 years ago when I did this, I put lights on it. And foolishly, I ran them off of track power. So when we turn the track power on, now we have lights that indicate direction of travel. And I'm just using these little, I think they're called grain of rice lights. Typically they're from Micromark, and they are pretty common. These actually are 12 volt, either AC or DC. They are not LEDs. LEDs were not really a thing when I put this together. And I don't think that I've had any problems running this off of track power, but I want LEDs on it now, and I want it run on its own power supply. Now the switches are not run by track power, obviously. Those are Tortoise, and if you're not familiar with Tortoise switches, switch machines, I'll do a little short run by on them as I get this build done. This is a Tortoise switch machine. It's made by Circuitron. They've been out a long time. They are very reliable. There is a stall motor in here, and it will take DC voltage, and it's put on these outer two contacts. The rest of these in here, this one's a little ugly. I repurposed it from something else. But these outer two contacts take the DC voltage coming in, and depending on the polarity, will twist that motor, which turns this little fulcrum here through a series of gears inside. You want to be careful moving these. It's really better if you don't, because you can strip the gear. So be aware of that. So this just moves back and forth until it hits the end, the stop, then it quits moving. And it'll still draw some current, but not a lot. From here, a wire fits in that little hole and travels upwards, and there is a little piece missing right here. That wire, it acts as a fulcrum, and as this wire moves back and forth, the top of it moves the opposite direction. That goes through the bottom of your layout. This is mounted underneath. That goes through the bottom of the layout, up into the points on your turnout. And as this moves back and forth, it moves the points over. Simple as that. These other unused contacts down here, that's part of a double pole, double throw switch that's inside this. And you can use that to do a lot of things. You can use that to run lights. You can use that to manage signals, any number of things that you would normally do with a double pole, double throw. That's a Tortoise. Here is the back of that panel. And I hope I'm a little smarter now. It's been so long since I've done this that I had to go back and reacquaint myself with how I actually powered it. Now the Tortoise, all of the machines, typically only a couple of them will work at a time, are run by a wall wart, 12 volt. And that power comes in here, 2 conductors, and this very highly technical connection device here goes out to each of these double pole, double throw switches. And they're wired up, as I will illustrate later, to simply reverse the polarity of the power going to the Tortoise, which makes the switch, the Tortoise stall motor, run. Now the power to the lights is coming right off of the track bus. And I don't think that's smart, but it worked back then. But anyway, it comes into these connections and goes through these terminals. Little resistors just to drop the glare of the lights down a bit. And those are just running the lights. And I'm going to change all that too. Okay, start my little project by getting a box of these switches from China. And they're pretty cheap. I think this was, I don't know, $7 or $8 for 10 or 12 switches. Plus the little screws to mount them to the control panel. And these are double pole, double throw. And I'll kind of illustrate what that means. Here I've got a multimeter attached to one of them. And the two, and take a look this way, switch flips this way. And it's just a 2-position switch, on or off. The middle pair are the common. And that's the contact that will flip to the others here. And I'll illustrate here on the ohmmeter. We don't have any continuity at all. I'll flip the switch and we have 0 resistance. So this switch is actually on. Now, when I take this little contact here, this probe, and put it on the other contact, you can see I haven't flipped the switch at all, but there's no continuity there. I'll flip the switch and we have an on there. So one of them is a normally open, normally closed. The other is normally closed. And that's how those work. The bank on this side works exactly the same way. Now you can get that to do some magical things for you, and I'll illustrate that with this next one that I have already done a little doctoring on. A little ugly and scary, and I'm sure on the internet you can find much better examples than this. Once again, switch flips up and down, and I have wired our incoming power leads to the 2 common. And in this case, this will just be a 12 volt DC signal. You'll have the plus terminal on the red one, and the ground or the negative terminal on the black one. And those come into those two middle position switch contacts. And what I've done with the corners, I've crisscrossed them. You can see from the upper left, there's a wire that connects it to the lower right. And from the upper right, there's a wire that connects it to the lower left. And I'll show you here in just a moment what that does. I have attached a little pigtail on here so we can do something with it. Be right back. Okay, I've got my power supply. And I'm going to set this on about 7.5 volts. I always bring it up slow. These things have a tendency to jump. Oh, I've got 7.5 volts, and this is just a supply voltage, nothing fancy about it. And come down here and I have connected it. I've connected the power supply wires to our incoming power leads that I showed you on the switch. And then on the other end of our little pigtail, I have connected our voltmeter. And if you can see right now, in this position, we are reading 7.5, negative 7.5 volts. I'm going to flip this switch, and all of a sudden we've got positive 7.5 volts. And if you know anything about direct current, that means you can swap the direction of a motor using this method here. So that in the case of a Tortoise, we're going to be feeding this with 10 to 12 volts. And when you flip this switch, the outlet here is going to swap the polarity going to terminals 1 and 8 of that Tortoise switch machine, and we will change the direction of that turnout. And something else I wasn't 100% sure that was going to work, but apparently it does, is I now have my power supply set at about 2.5 volts. And I have a 3-volt LED bi-color. And this is green. It kind of looks yellow on my screen, but I'm going to flip the polarity on that. I've just got 2 wires hooked up to it, and now it's red. So that's what I'm going to use on the control panel instead of just the white indicator lamps that I presently have. And how I'll make that work is I'll just take the exact outputs going to the Tortoises, Tortoisums, and I'll put some resistors on there to drop this voltage down, and we will have working panel lights, red and green. I wanted to show you the little light pairs. These are those red-green bicolor LEDs, and they are really cheap. At least they were when I got them. And LEDs, if you know anything about them, they only flow in one direction, except these, when you reverse the polarity on them, they will turn from red to green and vice versa. So what I did was took 2 of them and put them, let's get this where you can see it. Typically the shorter wire is the negative side. So if you see those wires there, I just rotated it and then soldered the 2 of them together like this. So when you put power coming out of one power source to those two ends, you'll get two different colors, one out of each one of these LEDs. Now I also put in line with these LEDs, I just soldered a 1K resistor in place, and that's to limit the amount of current going through it. And then cover that junction with a little bit of shrink. And in a lot of cases I didn't even bother to shrink it. All I'm trying to do is keep wires from getting crossed and touching each other. So that is the way I put together the little double light circuits that are light contraptions that are located very close to the switches. Here's the piece of styrene that I've drilled for the LED lights and the switches. For those lights, if you get the right bit size, they fit very tightly. That is an LM2596, one of the best voltage controls I have ever run across. And there's all those components we've been looking at, properly labeled and numbered. Makes troubleshooting a whole lot easier later on. I like to do things on terminal strips. It makes it possible to save more of the project if you ever have to tear it apart. There's one of those dual LED pairs with the resistors covered up by the heat shrink. And there it is with the power on it. It's a little washed out in the light there, but it's a lot brighter in the train room. There's the finished wiring job. Looks a little messy, but it's very easy to trace because of the numbers on the wires. I'm putting some pin striping on here to make those lines a little easier to see. I think that's 3mm, 1/8 inch graphics tape. Just use an X-Acto knife and a little bit of care, and it comes out pretty good. Nice and easy. Go to the garage, make a little frame to hold the whole thing in, and you're ready to go. Let's take the old one out of there. And again, I'm paying close attention to labeling the wires that go to the tortoises. Makes it a lot easier than having to crawl into the layout and go chase them. Bye-bye old control panel. And when installing the new one here, I'm just taking the two wires that go to each tortoise, putting it on the corresponding terminal strip. I'm not worried about polarity at this point because it is very easy to change them if one does go backwards. It's not going to hurt it, it's just going to run the wrong way. I'm going to put the power supply on it, and that's just a 12 or 15 volt DC wall wart. That LM2596 will knock it down to whatever voltage you want it running at. I think it'll take up to 40 volts input. And there she is lit up. I'm just checking, making sure they run the direction that they're supposed to, and of course half of them don't. So just swap the two wires, and now it works the way you want it. And there's the finished product. Thanks for watching.